We don't know 95% of the universe. Not an estimate, not a guess, not an exaggeration to grab attention, but a fact supported by decades of precise observations, astronomical measurements, and rigorous mathematics. Everything we see in the universe, the stars that light up the night, the planets that orbit them, the galaxies that resemble whirlpools of light, even the hot gases between stars, all of this, in all its beauty and simplicity, makes up only 5% of what the universe is made of. The rest? We can't see it, we don't understand it, and we can't detect it with any tool we have today. It's invisible, doesn't emit light, doesn't reflect it, doesn't absorb it, yet it fills the space around us with a gravity we can't see and a force we don't understand, as if the entire universe is moving by an invisible hand, and we only see its trace. Let's go back in time a little to understand what's happening. In the 1960s, the renowned physicist Vera Rubin was studying the motion of stars in the Andromeda galaxy, expecting stars closer to the center to move faster, while distant ones move slower, just like any solid body rotating around its axis. But what she saw defied all expectations. The stars at the edge were moving at speeds close to those near the center, as if the entire galaxy was spinning as one solid piece, not as a collection of freely rotating stars. This meant there was a massive unseen mass holding the galaxy together, otherwise, it would have torn apart billions of years ago. Rubin presented her results to other scientists, who doubted her, saying she might have made a measurement error or that there was another explanation. But she reanalyzed, studied more, and found the same result in dozens of galaxies. The mass we see, stars, gases, planets, isn't enough to explain the motion. There must be something else, something invisible, yet possessing gravity. This is what we now call dark matter. And it's not a literary term, nor a metaphor, it's a precise description. Matter that can't be seen, yet exists. It doesn't emit light, doesn't interact with light, yet it affects the spacetime around it through its gravity, just like any large mass. We don't know what it is, but we know the universe couldn't be the way it is without it. Without dark matter, galaxies wouldn't form, wouldn't stay intact, and stars wouldn't orbit as we see them. Every model of cosmic evolution collapses if we remove it. And strangely, this matter that holds the universe together makes up only 27% of its components. So, what makes up the remaining 68% is even stranger. And of course, since we've mentioned something new, we'll have to go back in time again to understand what's happening. I know you're a bit tired from the first time, but I promise you'll enjoy it and won't regret it. In the 1990s, two teams of scientists made a stunning discovery. The universe isn't just expanding, it's expanding at an accelerating rate. At first, we thought gravity would gradually slow down the expansion, like a ball thrown upward, slowing before it falls. But measurements showed the opposite. Galaxies are moving away from each other faster over time. As if there's a hidden force, distributed throughout space itself, pushing the universe apart, as if space isn't empty, but contains energy that expands spacetime from within. We call this dark energy, not because it's mysterious, but because we can't see it or understand it, yet its effect is clear. The universe is accelerating, and perhaps, in the distant future, everything will be torn apart, galaxies, stars, even atoms themselves, in what's called the Big Rip. Maybe we can make a video about the Big Rip and discover how the universe could tear itself apart. Tell me in the comments if you'd like that. Dark energy doesn't hold things together, it pushes them apart. It doesn't gather, it separates. It doesn't leave a direct trace in galaxies, but affects the universe's structure as a whole. While dark matter helps form structures, dark energy works against it, pushing the universe toward total emptiness. And even though we don't know what it is, cosmic background measurements and galaxy redshifts all point to its existence. From all of this, we conclude that the universe is made of 5% ordinary matter, what we know, 27% dark matter, invisible, but holding things together. 68% dark energy, invisible, but expanding space. Add it all up, you get 100%, but you only understand 5% of it. Some think we might be wrong about gravity, that Einstein was mistaken, and we don't need two dark things to explain the universe. But the problem is that general relativity works extremely well everywhere we test it, from planetary orbits to light bending around black holes. How can we reject it just because it leads to strange conclusions? The universe moves according to laws that don't care about our feelings. The most important question, will we ever discover it? Dark matter? Maybe. There are experiments deep underground, in tunnels beneath mountains, trying to detect rare dark particles passing through Earth without interacting with anything. Like the LUX experiment in the US, or xenon in Italy, where a massive tank of pure xenon is placed under kilometers of rock to shield it from radiation. The idea is that if a dark particle passes, it might collide with a xenon atom and produce a rare flash of light. But after decades of searching, nothing. No flash, no collision, no evidence. Dark energy? Harder. Because it's not a particle, it's a property of space itself. Just as space isn't truly empty, but filled with virtual particles popping in and out, maybe there's an inherent energy in space that pushes the universe apart. Some call it the cosmological constant, others think it might change over time. But no one knows. And you, right now, on this small planet, watching this video, thinking about a small problem, a distant dream, or a video you want to watch, you're living in only 5% of reality. The other 95% is holding the galaxy we live in together, pushing the universe apart, making everything around you possible, without you seeing it, understanding it, or even feeling it. You might think this takes meaning away from life. But the opposite is true. Being here, in this mysterious universe, questioning it, realizing you don't understand it, that's what gives you meaning. Because curiosity, questioning, and searching, these are the deepest parts of you. And the universe, in its mystery, allows you to do that. And this, perhaps, is the most important reason for your existence. And if you ever figure out what dark matter or dark energy is, know this, your name will be written in history. Because whoever explains one of them, just one, will win a Nobel Prize. Not an exaggeration, not an empty promise, but a fact. Scientists know this discovery would be among the greatest humanity has ever made. It might not change your daily life, but it will change how you see the universe. And maybe, at some moment, you'll think, could I have been the one to discover it? Why not? Don't let anyone tell you something is impossible. Because the lazy don't just get tired, they just say, this is impossible, so they don't have to keep working or trying. Science isn't built on genius alone, it's built on questioning. And if the universe were to write its own story, it would title one chapter, Don't Think Too Much, Just Ask. If you benefited from this video, don't forget to like, subscribe, and hit the bell. Because we have a journey coming up, I don't know where, but it will definitely be worthy of us. I'll see you on the next journey.